Good afternoon, everyone. How are you doing today?
Good, sir.
Nice, nice, nice. All right. I'm seeing only 10 of us. I'm seeing only 10. I'm seeing only 10. All right, let me give you. Let me give another 5 minutes, and then we will begin. Another 5 more minutes. All right. All right, guys. uh, I just I would love to get your feedback on a matter, just totally unrelated. Um, it's just a thought that comes to mind, and I value your opinion. I want to know. I want to look at things in a different light. No, there's only one student that joined within the 5 minutes. I'm going to begin. No, say you're walking on the road, wherever you are. It could be at home. Say you're held up, gunpoint, knife point. It could be a water gun. It could be a pen or a pencil. You're held up. And him say, hand up. And I just stereotype a while ago when I said himself, because there have some females out there who do this up. The robber says, hand over. Would you hand over?
Yes, sir.
Why?
Sir, I always say this. My life is more valuable than anything. So even if a pen, it doesn't matter the value of it. I'm giving it up with I'm not resisting. I'm not doing anything because sometimes I hold on to things that bring me down. Because him go shot me in my spine, my cripple or something got happen. When I could have just give him, and sometimes when you lose something, you get something bigger. I don't know. I'm just look on it positively. So yeah, that's the reason why I won't resist anything. Yeah.
And I hear you and I respect your comments, and I also seen Jermaine's comment, and I am also respecting it. Anybody else? I mean, I won't take long on this, so just chime in quickly, please.
He will speak
Sir?
with God and you will be able to
Sir,
understand
Yes,
I
the
I'm
word of
here.
God. I
agree.
pray that
I agree
he
with
will
them.
be able to
The
walk
only
with
point when
God. I pray
only
he will be
point
gentle
if
and
it comes to a
understanding
point where
like
they say that
Maya
come with me in a
and the
car,
children
no,
of
that's a
God.
different situation.
I pray
Because you don't
Sorry,
know
that
what they
you
might do.
will
what about?
interact and that she
If they
will not
say to
have any
come with them
personality
now, no, that's
under
a
the
different
person.
In
In
a
situation.
the
car.
mighty.
Oh, yeah.
Father God, I pray.
Yes.
Okay,
Because then
all
they
right.
can
I
carry you go
pray
anywhere now
that
and do whatever they
he
want to
will
you.
be healthy, that he won't have any.
Mm-hmm. All right, fair enough. Anybody else? I take two more. So I hear from three. I just take two more. Anybody else? Please, somebody just tell me, talk to me. Okay.
I mean, sir, I agree with I can't pronounce her name, but I agree with her because my life more have more value than whatever it is that they're taking from me.
Yes, Rashid. It's just again, Sash again. Read the message. Sorry, Rash. I agree with you. Yes, Rash. Yeah. You know, guys. You know what Sash tell me? All if him want the clothes, she'll give him the clothes, right?
As long as I'm not gonna take car with
No. She not get nothing else. I just a clothes she'll give him and run with him. All right. You see, I asked the question because I was held up at gunpoint at my yard gate. Not recently, I should say. Hasten to say, not recently. So, so I was held up at gunpoint. You know, funny story. I was at it said, um, I remember I had finished a chemistry class 3 o'clock to 5 o'clock, and one of my chemistry students was going through a hard time, and him say, "Mom, to talk to me." And I said, "All right, after class we'll talk." And I sat down, spoke with him for about an hour, left exit about 6 o'clock, reach home, the 7 o'clock bells. And just as I was closing the gate, I saw a light coming down. And I said, that light looks like my wife coming in. So I stood up at the gate, trying, waiting for her to come. And this man walking on the avenue. So from I see the man walking on the avenue, I know something was going to happen. I sensed it. I know something was going to happen, but I couldn't I couldn't move. Why I couldn't move? Because I saw the light of the other car coming and I know whose car it was. So I couldn't go inside and leave her out there alone. So I stood up. This germsy person came and lift up his shirt and put a gun on my stomach and say, give me the car key. And I said to him, that's all you want? I can give you another car key, because funny enough, I had visitors overseas and they had blocked the car park. So that's why I was outside for so long. Now I'm allowed to just drive in, I'm a done. I say, you want another car key? You can't get it, He say, yeah, give me. So I say, man, send me the car key. It was a rental car key. I say, see, take that. I had a BlackBerry. Give me the phone. I said, take the phone. He said, take the phone and go on. Then I saw Huawei boy. And then I saw another guy walking. And I said to myself, good. At least somebody know is seeing that he's holding up with a gun, not recognizing that this was his accomplice. At which point in time, my wife got to the gate and this guy pulled the car door, ladies, gentlemen, drive with the car door lock. Him pull the car door and go into the car with my wife with the gun. Long and short is, him say, him want the car. And she said, she not come out of the car. So me look on her and said, come out of the car. And she said, no, I'm not coming out. And he said, come out of the car. All right. And when she came out of the car, they stole the car and, that. And she was shaking up. And I was like, okay, what just happened? And then the guy crashed the car in front of us. Well, ran the car into my neighbor's car. Sometimes in life, we complain about some things and some things are there to save us. So my neighbor across the street always have his visitors who come and double park. So I can't get into my place because of the double parking. And he said, so we don't want to be that neighbor that people hear about. So I don't say nothing, but it used to annoy the crap out of me. This particular night, I was so darn happy because you'll have to live where I live in order to maneuver that park. Don't tell me say you're a good driver. You have to know how to maneuver the park. And so of course, he's the first time doing something like that and didn't know what to do. So he ran the car into the side of my neighbor's car, set off the alarm, and neighbors started coming out. I said, but wait, I know you're here to go up. I said, yes, I was just held up gunpoint. Long and short is that they found the car, la-di-da, whatever else. And whatever else. Yeah. So when I went to work the Tuesday morning, I was saying to some of them, my students, that I was held up last night at gunpoint. And some students, I said, oh, you idiot, we need to give the car. I said, that's why I am still alive. Because I have sense. The more the car, give them the car. It's material stuff. I asked the question because I'm looking at a promising only child that was murdered along Ligoni Avenue yesterday. Student from Papine. It's an avenue that I traverse. As a matter of fact, that night when I was held up, that's the avenue I drove on to get home. I drove on the avenue today and I was just shaken up with, guys, the man shoot the woman Pitney, our uncle Pitney. The lady say what? In a cruel piece of tales, the St. Andrew mother is now grieving the death of her only child some 13 hours after she ironed his suit to wear to her wedding this Saturday. Kenneth Williams, a student of Papine High in St. Andrew, was killed around 11:30 while walking to school along Ligonier Avenue in the parish yesterday. Imagine somebody can say a school youth with them cell phone, a school youth, with them cell phone. So we have come out of one pandemic and the youth would all use them cell phone for online class. The youth would all upon class and I got through and you shoot the youth and left the youth, shoot the youth and then run. It's a passerby. See the youth on the road, and stop and can't go hospital. And youth now move and take up the youth and can't go hospital. Kill a woman picnic. Ah. Let me just want enough, you see? Let me want enough. Good and proper. If a man come and say, he want a cell phone, I don't care if he just spend 15 or 16 $100 US for the phone, give it to him. Your life is much more precious than going into a box with ice. Give it to him. Give it to him. Make him go on with it because chances are.
If you give it, sir.
Yeah?
All right, sir. My opinion still is when it comes to vanity and them stuff, things are replaceable. Me not really stress about it. So if a man come to me and want my vehicle, me just give him and say, go on. Because at the end of the day, me know I might take it hard, but at the end of the day, me eventually I get over it and me can eventually get another vehicle. Sometimes things just happen very easy, you know, sir. So that's how me look on it more while, you know.
Next time you come like you're my brother. You come like you are my brother.
Same so next time. Same so. Just have a drink around and forget it. Sir, I serious. I real talk, man. That's how me look on things, you know, sir.
Next time, I said, no, but no, you're right. What I said to you next time is that the car that we gave up was a new car. And I said, go, because I mean, you guys wouldn't have known me. This happened about 2009. You guys wouldn't have known me. All right. And I remember when I stood up there with the gun on my stomach, I say it point at me, you know, the gun literally touched my belly. I'm a look down on the ground, and I was just visioning the blood running down on the incline, and I said, nope, I will not die this way. Mr. Bridget, where you want? Me, I tell you not, if you know anything about biology, think of anything they call peristaltic constriction. Means that everything inside the intestine just liquefy. I squeeze me off a squeeze, you know, myself. Because me I said to myself, said, Jesus, I just never did. I'm a yard gate. Me said, no, Father. I said, that's not how you wrote the script. Me can't tell you, Father, and I saw you to write the script. You know, I'm happy that they have a suspect. Yes, Papa.
I've seen too much CCTV camera footage of persons trying to resist. There was one in, well, I think it was Lincoln side as well, where a bike man was delivering pizza, and the man them come up right behind him and pull a gun. Him try to run off, and him just shoot him.
Oh no!
A lady was there walking on the street. I can't identify where exactly, but she was walking on the street.
Or the one in Linstead, when the bike man just come grab her bag and jump on the bike?
No, it was the one whereby she was walking with a phone in her hand. And the man right past and tried to grab the phone, but missed the phone. And him just turn around and come back for her. And she tried to run the other way, but another one just come right behind her.
Oh no!
So them working at peers, always suspect that she gonna have a friend. And there's another video on Facebook whereby like one Ras they walk down in a like a alley like way. A man come right behind him. You know the choke hold where if knock you out? And grab him that way. And the next man they walk this opposite direction, just come and dip him on them and pocket. And just left him down on the ground like him there gas for ear.
Yes, I saw that.
Take away. All right.
Knock
Now
him
them
out
catch
in
them still,
like
you know.
5 seconds.
Yeah, man, them catch them though. Don't catch them. But still,
it's because I am being recorded. You can talk to me afterwards how I think they're supposed to treat them. You know, it's hard. It's hard for a mother send a child to school at William Nib and them fighting over a guard ring and one take a knife and stab the other one, kill him. It is hard right in our backyard at Excelsior that a grade 11 student was stabbed yesterday on campus, right? I don't even know the status of the student now, all right? Right over the high school. That is too close for comfort. Very technical high school, 2 girls are fired, all when the teacher them in the middle of them. And you know, one of the things, this is my final point and then I move on, forgive me. You know, one of the things that I remember, oh Lord, this is before the pandemic. I remember I was sitting in my office downstairs on the second floor and heard a commotion upstairs. And I said to myself, you know what? Me not going to no commotion, because them people not have no behavior. And me not going to no commotion, go take no lick for nobody. No, negative. And the commotion was getting out of hand, so I decided to go upstairs. When I went upstairs, I saw a fight. And I decided that I was going to go between the two people them to tell them, say, oh, no, for go easy. And I remember one of them said to me, say, man, you lick me, no? Me said, just be careful. Say, me, I look on. It was two girls. I said, man, you lick me, no? And the girl said, Mr. Shan, come out of the way. Me said, me nah, come out of the way. But me said, don't lick me. No lick me. I thought that students who were around, who were jeering the more aggressive of the two, would have tried to calm her, so forth and so on. The man, them have them cell phone out on a video. And I'm saying to myself, the fight that I saw on TikTok last night at Very Technical, the students, they're cheering each other, have cell phone out and videoing the fight, as opposed to pulling someone and say, no, Charlene, it can't be doing that. You and Sasha too good of friends to do that.
Them, you know. Fun until them see it get serious, you know, sir. I say it gonna nowadays with them picking.
No, but guess what? Until when it gets serious, it's too late, because it means that there's a knife is in the person's chest. It's too late. No, listen to me. Me and God have a conversation, you know, because me no thinks after spending about 25 years in the classroom as teacher, me think it's time for me to call it quits. No, because me don't know it. Norman Manley. I saw a video of Norman Manley. Two boys, a stab-up teacher, and you believe that the students would try to intervene. No, they are jeering and they are going on and they are encouraging. You know, guys, I'm just telling you, we have to do what we need to do. And one of the things that we need to do is just to use common sense here. Use common sense. Yes, I know you had to purchase this stuff and, you know, do what it is that you need to do with this stuff, but serious times. Serious times. So just be careful, please, I beg of you. It's very, very, very important that you need to be vigilant wherever you go. All right. Now, there was a question that was posed in the WhatsApp. Didn't get a chance to respond to it. I acknowledge receipt of it nonetheless. And just allow me now, question 4. Let me put a 5th question here. Just allow me now to just walk you through that question. Call that question 5.
Sir, before you start, you made a mistake with one of the vertical asymptote. You copied one and didn't make the change to the other.
Oh, so I copied the answer for one of them for a previous question. I never made a change in it.
Right.
Okay, come on. I mean, guilty as charged. You know that. I mean, without even knowing which other questions they're talking about, guilty as charged. You know me love copy and paste, right? Like I'm doing right here now with question 5. All right, I will look at the vertical asymptote a little later on, so that we can make adjustments to the document. All right, so I think you need.
Before you start, up at top it has a read only.
Oh crap! I hate when it happens like this. All right, never mind. It's just that I have to save it as a different name, and then all right, thank you, Papa. All right. So Yannick, place a question in the chat, I have to use it still because I mean I started making some adjustments. I don't even know what not to do. Anyway, it says something about let me see if I can find the question. Can somebody read the question for me, please? The one that was posted in the group by Yoni.
All right,
Somebody?
sir, I'm coming. Find an approximation of the square root of 37 using the method of small changes.
Ah. All right, so find the approximation of the root of 37 using the method of small changes. All right,
Okay.
so what we're, all right, thanks, son. What we're going to be doing is utilizing the same sort of formulation that we were introduced to. Squiggly y is approximately equals to dy by dx times squiggly x. Squiggly y is going to be equals to dy by dx, approximately equals to d by dx, because remember, we're finding an approximation. It's not the exact value that we're doing an approximation. So we're going to say squiggly y is approximately equal to dy by dx times squiggly x. Remember, squiggly y is what it is that we're trying to evaluate, and squiggly x is going to be the change, the small change that occurred in the approximation. All right. So just remember, squiggly y approximately equals to dy by dx times squiggly x. Now you're going to ask the question. You're going to ask the question. How are we going to get dy by dx from something like this, sir, when there is no variable? Good question. So what I'm going to do here, and so I'm going to let, hold on. So I'm going to let, I'm going to let y, oh crap, undo. I love copy and paste. Please copy. I'm going to let, all right, hold on now, my system. All right, so I'm going to let y paste. I'm going to let y be equal to the root of x. It asks me to find a root of 37. Okay, let me ask the question first before I even go any further. Can anybody guesstimate what the square root of 37 is going to be? Somebody just guesstimate and just tell me something.
6 point some.
6 point something. Excellent.
2.
Excellent answer. Excellent answer. Excellent answer. I'm proud of you. It means that your brain space is going. Excellent answer. How we got 6 point something? Because we know that the square root of 36 is 6. So that means 37. And we know that the square root of 49 is 7. We are closer to 36 than we are to 49. True or false?
True.
Right. So we know our answer is closer to 6 than it is to 7. So if you ask me, sir, what is the approximation of the root of 37? I'm going to say the 6.1 to one decimal place. I am just going to say the 6.1. We're not go more than 0.1. You know why? Because that is 37. And I know 36, the square root of 36 is going to be 6. Now, if that had been like the square root of 45, I know it would be like about 6.8. Talk truth.
Sir.
They're closer to 7.
Because it's closer to 7. It's closer to the 49. Excellent. So I'm happy that you're seeing that. Thanks, Sash. All right. So let's go. So we're looking at the square root of 36. I'm going to let y be equal to the root of x. I'm letting y be equal to the root of x, right? And I'm going to say where x why am I in this? All right, let me just fix it once and for all. Hold on. Where x is the unknown, right? So I'm letting x be the unknown, all right? So we're going to be guessing a number. So we're going to be guessing a number. So we're going to guess GUESS. So we're going to guess a number that is close to 37 and a perfect square. Why a perfect square?
No remainder.
It's a rounded number.
It's a rounded number. And remember, I'm finding the square root. You see that?
Yes, sir.
So if I was finding the cube root, I'll find a number that is a what? That is cubed, don't it?
Yes, sir.
All right,
Yeah.
good. All right. So I'm going to guess a number, and of course, guess a number close to 37 and a perfect squared. So I'm going to guess 36. So I'm going to let x to be equal to 36. All right, so I'm going to let x equals to 36. Now, based on what it is that we have been doing, and look at this down here. Squiggly y is equals to approximately equals to dy by dx times squiggly x. What is squiggly x again? I told you last class. What is squiggly x? What does it represent?
The difference between.
Very good. What will be the difference for squiggly x now?
1.
Very good. So squiggly x, oh, come on. And squiggly x is going to be equal to 1. Remember, we're trying to find squiggly y. Squiggly y, we still don't know. We can't take out that.
Where come I add 1?
Huh?
Okay. My bad.
All right, no problem. I'm happy when you can see it on your own. All right. So for those of you who don't see it yet, we came by the 1 because we started off with 37 and we are only guessing 36. So we know that our change is going to be 1. So squiggly y is what it is that you're trying to find. We know that x is equals to 36 and squiggly x is going to be equals to 1. So what we're going to be doing now, remember, now we're in calculus. So everything we need to start thinking differentiation. So we now need to find dy by dx.
Very right, that, sir.
Yeah, very nice, Lexton. Very nice. All right. So my y equals the root of x. I'm going to have it as y equals x raised to the half power. And when I differentiate x raised to the half power, I'm going to get 1 over 2 the root of x. Sir, You know, see it. All right, not a problem. Let me just do something here. All right. So when I differentiate this half is going to come in front. So it's going to be a half x. I always subtract one from the power. So it's going to come a half x to the minus a half. So this 1/2 is going to multiply in front of the not the parenthesis, but in front of the x. And I'm subtracting 1 from this. So a half minus 1 is going to be negative a half. And then this negative a half is the same thing as putting this x. In order to convert the negative a half to positive, I'll have to put the x to the half in the denominator. So let me just kill 2 birds with 1 stone by doing a little review on this thing here, so you can see what I'm talking about. So I'm going to have x to the positive a half. And x to the positive a half is the same thing as writing the root of x. All right? So I know what my dy by dx is. Now recall the formula. See the formula here? The formula says the change in y is going to be equals to dy by dx times the change in x. No, if we look at this, we know the change in y is what we're trying to find. And we know that dy by dx is equal to all of that. So what I can do is to say, copy, paste. 1/2 the root of x. And the question is not this long here, it's just that I'm typing and doing the stuff. I really want to show you what it looks like. Times 1. No, undo. Let me not do it like that. Then I copy this now, paste again. No, I want to copy you. Copy. All right. So what I'm going to have now, I'm substituting my dy by dx. Let me just get rid of this here. I'm substituting my dy by dx times my change in x. But I know that my x is 36. So where you get that from? See here? I am letting x to be equal to 36. Then, sir, let me ask you a question. Could I make x 35? If you make x 35, you're not going to get a perfect squares. I think, was it Lexon? Somebody said it in class. We need something that is a perfect squares. So I'm not going to look at 35 because 35 is not a perfect squares. Okay, sir. Then what if I use 25? You tell me, what is going to happen if you use 25? Is that close or is it too far off?
Far off, sir.
It's way too far. Way too far off, man. You're trying to get as close to the number as you possibly can. Small changes. You're trying to get as close to the number as you possibly can. So I know that my x is 36, and I know the root of 36 is 6. So I'm going to have all of that. I'm going to have all of that. Sorry, I'm typing. Times 6. as I said before, I am typing it out so that you can all, why is this thing not coming out? Sure. So you can see what it looks like. The question is not going to be this long. All right, so I'm going to have 2 times 6. I'm going to end up with 112 because 1 times all of that is just going to give me 1. So I'm going to have all of that there being equals to 112. Now, is that the final answer?
That look like it, sir.
Yeah, but remember, no, it can't be just 112 alone, no. One to the original number. Let me just write it. Let me just go back to what it is that we did for some differentiation some long time ago. Some long time differentiation. And I want to see if you guys, yes, honey.
So you're going to put it back in the square form?
I'll have to put it back there. Yeah, I'll have to put it back there. All right, look at this here. When you say f of x plus h, what do you remember? What the topic?
First
First
principles.
First principles, man. First principles. Yeah, man. I remember Sir said to you, as h tends to 0, and I always said to you that h is a small change. Anybody remember that? No? Nobody remember when Sir says h is a small change?
Sir, it's small in memory.
Yeah, man. So I said to you that f of x plus h is going to be very small. It's a small change. And that small change, now, when it is that you have incorporated that small change, you're going to take back your original function, and then that small change is what it is that you're left with, and which is going to give you the differential. So in this here case, I know we're going to have my f of x plus my f dash of x times h, which is my small change here. So this small change here is going to be 112, right? And my f of x is going to be the root of 36, which is going to be 6 plus 112. All right, so let me just write that there. Let me just put it in here. You see, it comes back the root of 36. Everything that we're doing, it carries forward. I don't want you to think that the question is long. The question isn't long. The question isn't long. I am doing this because I want to type it out so that at least when you get the handout, you are seeing what I'm having here, right? This is this can't be more than 3-4 marks. How many marks they give you for that? All right, so my f of x is going to be the root of 36 because remember, I'm changing the question now, right? I'm changing the question. My f of x, my function f of x is equals to y. But if I am letting x to be 36, what I can have is y equals the root of 36, which is what I have here technically. Y equals the root of 36 plus my small change here, which is 112. So I'm going to have now 6 plus 112. So my f of x plus h is going to be equals to the root of 37 incidentally. So I can change this now to the root of 37. And I can also change there to the root of 37. And then, what is 112? Somebody find that out for me, please.
In decimal, sorry.
Yeah, in decimal form.
0.083.
Would it?
Yeah, to 3 decimal places. Yeah. All right, thanks. So that's how I'll get the approximation to be 6.083. I knew it was going to be 6 point something. I knew it. How, sir? Because we went as we found a perfect square close to the number that we are looking at, which is 37, and the closest square perfect square number we're talking about is 36. So we are starting with 36, but don't start with 25 because 25 is too far off, and we're talking about a small change. We are referring to a small change. All right. So we start off with our 36, and then now we're going to look at that small change to be 1. And then we'll go through with the question. You all saw what I did. Are there any questions?
Not really a question, but I saw I can call it now a small pattern here.
Mm-hmm.
All right, so I did it. I thought it would have been the same 6.083 because I was checking. If I can scroll back up a bit, let me just look back at something. Scroll back down. Right there. Right there.
Mm-hmm.
Yeah. So so I realized that you had mentioned that dy by dx is 1/12 and the small changes are already 1, right? So I would say I was thinking that you would want to find but the square root of 36 and then you do the calculation that is there, which give you about the same 6.083, which
Mm-hmm.
is also the square root of 37.
Yeah.
Mm.
Yeah. What I'll do is I don't want to consume too much of our time on this particular example. I can write you some other examples just for you to try in the interim. But I like what it is that I'm seeing in terms of me teaching and you going into the past papers and trying to get questions to work. Very good. And send them on. I will do the very best I can. If not immediately, I will definitely do it. I know last time I sat down after class to do the question, and now I start off the class with this question, just to keep us going. All right. Question: Is there any difficulty with it? Are you all seeing what is happening here?
Yes, sir.
All
For
right.
Yanni, I don't know about anybody else.
Sir, the
All right.
farthest good I reach are probably the 112. Whenever did I think about the first principle?
Yeah, and you see, and let me tell you something. You see, when you reach right here, so when you reach 112, I am only showing you here so to show you that boy, the f of x plus h is going to be my original plus my increment. And this is my original plus my small change. Plus my small change here. So I'm just bringing back now the whole business of first principles to you to show you exactly what is happening. So if you had moved from this 112 and then go ahead and add your 6 to it, I wouldn't kill you. But I want to show you where I got the 6 from, because next thing you say, sir, where you get the 6 from? So I had to show you that from here, this piece here is what it is that we would have used originally in BizCalc or in Calculus 1 when we were doing our first principles differentiation. That I know you all know how to do. All right. And then from there, we just go ahead and just add back our 6 and we get our other question. As I said before, I can generate some for you. And you start doing the stuff. As I said, it's a good look to see, work beginning, on the past papers. A move that I will recommend 100%, a move I want you to always continue engaging in. All right. So if there are no further questions, just allow me to jump across. Allow me to jump across. I want to jump across to somewhere, but it's not giving me the option to. because I don't think I opened the document. So smart. So we're in our unit 2. We're in our unit 2. And let me just give you a quick little thing here. I don't remember seeing it on your syllabus, but let me give it to you nonetheless. I'm not coming in very hard tonight at this. It's gonna be a pretty smooth sailing until, and I'm not spending long on the mean value theorem. This is pretty easy to understand. Tiana should remember this very well. We did a lot of this, and we also looked at this in our calculus 1. Maybe not with the same formulation, but what it is that we would have done, it would have worked out to be the same thing. All right, let us look at this here. So we're saying that calculus boasts 2 mean value theorems. And there are times we'll go into the exam and say MVT. MVT, mean value theorem. So calculus boasts 2. One for derivative, one for differentiation, one for integration. So calculus boasts 2 mean value theorem. We talk about mean value theorem for differentiation. We talk about mean value theorem for integration. I'm just going to briefly show you the mean value theorem for differentiation. Why? Because I don't remember seeing it on the differentiation something, and I said to myself, let me, or maybe it's there and I overlook it, but I said, let me just put it in here, even though I am now on applications of integration. Let me just put this in there. All right, so I want you to look at it. So the mean value theorem for differentiation, if f is continuous on a closed interval AB, and it is differentiable on an open interval A comma B, then there exists a number C in AB such that f prime of C, which is the first differential at the point C, is going to be equal to f of B minus f of A over B minus A. F of A would be your interval. B is the upper limit, A is the lower limit. So you always subtract the lower one from the upper one. So it's always going to be f of B minus f of A, and it's going to be B minus A. That's what the mean value theorem is for differentiation, right? Now, I want you to get into the graph. I was sketching a graph here, but I want you to get into the graph. Let us look at, so there's a value C that is contained in here, right? There exists a C that is contained in my interval A, comma, B. Watch me. It says, given that f of x is equal to x cubed plus 4x for the interval -1, 1, I'm supposed to be using the mean value theorem in order to find that value. So look at what is happening. I'm using my upper limit. So I'm going to find f of 1. Anywhere in the function f of x, I see x, I put 1. So this becomes f of 1. Well, I did it the reverse. F of 1 is going to be equal to 1 cubed plus 4 times 1 And 1 cubed is 1 plus 4 times 1, which is 4. 1 plus 4 is equal to 5. I'm also doing it for -1. Anywhere in the function xic, anywhere in the function f of xicx, I'm going to put -1. So this now becomes f of -1 is equals to -1 cubed plus 4 times -1. Always remember, when you raise a negative number to an odd power, your result is negative. So -1 to the third power is going to be -1. And 4 times -1 is -4. So -1 minus 4 is going to give you -5. So this endpoint here, when x is -1, y is going to be -5, which is why I have -1 comma 5. When x is 1, my y is going to be 5, which is another endpoint. So I have two endpoints. One endpoint is -1 comma 5, and the other endpoint is going to be 1 comma 5. And the endpoints will be A and B. So see the endpoints I'm referring to here. This does not refer exactly to the question that I have on screen, but it's just the idea that comes. So it's going to be one endpoint here, A, and the other endpoint here, B. All right. So you have your endpoints. Now let us look at the slope of the endpoints. Let us look at the slope. So what is the slope? The gradient. Remember, we're doing mean value theorem for differentiation. We're looking at the mean value theorem for differentiation. And what a lot of us teachers didn't tell you, and I'm hoping that the teachers know that this is what they're doing. What a lot of us teachers never tell you when you're doing coordinate geometry and finding the equation of a line and the gradient of a line, you finding the gradient of a line is actually differentiating, y2 minus y1 over x2 minus x1, which is the slope. The slope is the differential. The slope is the differential. So I remember, doing AdMath and CXC maths pretty much at the same time. You recognize this sort of relationship. So when you go into the exam and give you a question to find the slope of the function, and you're supposed to use y2 minus y1 over x2 minus x1, if you go ahead and differentiate the function and do what you're supposed to do, you can get your answer. So when you're marking for the CXC exam, if a student has a prior knowledge and differentiate the function instead of using the y2 minus y1 over x2 minus x1, we still have to award full marks. All right. So when we look at the slope at the endpoints, we are actually differentiating. We are finding the gradient at that particular point. So y2 minus y1, this of course is my x1 value, my x2 value. This is my x1 value, my x2 value. So I'm going to have, if I call one set y1, x1, and y1, that means the other value has to be called x2 and y2. So let me see which one I use as my x1. All right. So x2, y2. Sorry, let me see if I can just do something here. y2. y1. All right. So I'm showing you that this is my y1. Can't be y1, sir, Sean. It has to be x1. What is wrong with you? x2 rather. All right. All right. So this is my x1, my y1. I can't have x1 and then y2. So if I'm using this as my first set of coordinates, it's going to be x1, y1, and this will have to be my second set of coordinates, which is x2, y2. So therefore, substituting it in this formula, y2 minus y1 over x2 minus x1, wherever I see x2, I'm going to put -5. So it's going to be -5 minus y1 is 5. So it's going to be -5 minus 5. See right up here, so? And then my x2 is going to be -1 minus 1. See right here, so? -1 minus 1. So -5 minus 5 is going to be -10, and -1 is going to be -2. And -10 divided by -2 is going to be equal to 5. So the slope is going to be equal to 5. All right? The slope is going to be equal to 5. Now, I asked the question, what similarity does this have to f? F of c is equal to b, f of b minus f of a over b minus a. Does it be the same slope? Let us check. So I am saying to you, we are finding the slope using y2 minus y1. I'm giving you some formulation here to say f dash of c is going to be equal. Oh, but sir, f dash of c, another slope at the point c, sir. And if you just found the gradient here, that means the two of them supposed to be the same. All right, let us check to see. So if you're looking at f of c says it's going to be f of b minus f of a over b minus a. What is f of b? Anybody remember what f of b was? Remember, this is a, this one is a, and this one is b. Let me put that there. I don't want anybody to have a difficulty when you're going through. So let me just, when I was doing the notes for you, I didn't have to do it because it's online. I want you to see what does that mean. Right. So we have our f of a and our, sorry, we have our a and our b. Remember now, it's going to be f of b minus f of a over b minus a. Your b is going to be the bigger value. All right. And it is closed. All right. Now, what is my f of b? My f of b is when I put b into the given function. When I put b into the given function here, which is f of 1, which is my f of b, this thing is, it takes a lot of time, which is my f of b, I'm going to get 5 for my f of b. I'm going to get 5 for my f of b. Let me look at my f of a now. My f of a, which is -1, is going to be equal to -5. So if I go through the formula, f of b minus f of a, f of b is 5. See here, f of b is 5, and f of a is -5. It's going to be 5 minus a -5. See here, so 5 minus a -5 over b minus a. But remember, b is +1 and a is -1. So it's going to be 1 minus a -1. So when we look at it now, 5 minus -5 is going to be +10. And 1 minus -2 is going to be, 1 minus -1 is going to be equal to 2. So I still get my 10 over 2, which is still equal to 5. So it does. It is equal. It is equal. It is equal. All right. What the question asks me to find, given that. Okay, right. Right. So it is equal. So whether or not I find the endpoints, or I go about using my f of b minus my f of a over b minus a, I will still end up with the same answer. I'll still end up with the same answer. Look at this here. So if I recall here, my f of x is going to be equal to x cubed plus 4x. This was my given question. Now my f dash of x, when I differentiate the function, I'm going to have 3x squared plus 4. right here, so 3x squared plus 4. No, my f dash of c is 5. So how you get that? See here, so remember, you know, this will be my differential. It's actually f dash of c is equals to b, f of b minus f of a over b minus a. So I left off my dash right here. Copy and paste. Oh boy. All right. So my f dash of c then, which is equals to 5. My f dash of c, which is equals to 5, is me setting this function here, 3x squared plus 4 equals 5. But I know that there is a number between, there's a number that exists between a and b, that is contained in a and b. There is a number that is contained between a and b, and I'm going to call that number c. So I now need to find what that number is. So when I substitute the differential to be equal to f dash of c, now differential is equal to differential. I'm going to have that number c that I'm going to substitute for, because that's what I know is contained in the interval AB. So I'm going to have 3c squared plus 4 is equal to 5. And when I'm trying to solve that, I'm going to have 3c squared is equal to 5 minus 4. And I'm going to get c squares to be equals to 1/3. And when we square root both sides, we're going to get all of that. And you don't need to know the rationalization, I guess not. All right. So this is a value of c that is contained in the interval AB. Now, if you
Sir,
look back at this, go ahead.
where you get the 4 from, sir?
I differentiate it. This 4, I differentiate it.
Oh,
And how I got x squared, I differentiate it. You follow?
yes, sir.
All right, good. So I just want us to check before I move into the integration part. As I said before, I only thought of doing this because I didn't see that, and I need to double check the mean value for differentiation. So I'm saying that the value of c, remember now, come again, your f dash of c is going to be equal to f of b minus f of a over b minus a. If f is continuous on the closed interval a comma b, and it is differentiable on the open interval a comma b, then there exists a number in c, a number c in this a comma b. So within this particular region, there is a number c that when I do my differential, I can find it. So f dash of c. So when I find my differential and substitute c of it, f of c in it, I'm going to find that number that lies within this particular range. Can somebody evaluate the root of 3 over 3 for me, please? Evaluate the root of 3 over 3 for me and tell me what you get. Hello? Hello, somebody? Am I muted?
What's the question, sir?
I wanted to evaluate the root of 3 over 3 for me.
The root of 3 over 3.
Mm-hmm.
0.5 8
Zero,
58. 0.58. 58.
5, 7.
577. Sorry.
0.577. Okay. What was my interval again?
-1, 1.
Very good. Does 0.577 lie between -1 and 1?
Yes, sir.
Right. So that's what it is that we're talking about. So in the differential, in my interval, A comma B, there lies a number C between those numbers that when I go ahead and find my f dash of C is going to be equal to f of B minus f of A over B minus A, I can evaluate the number. Now, what I normally see, where I normally see the answer a lot of these questions is merely in the multiple choice. By using the mean value theorem, determine whatever it is, C, and I can find a multiple choice question I give to you. It's not necessarily to teach you the question, but to show you what it is that we're doing. All right. So the mean value theorem for differentiation is going to be f dash of C, which is going to be equal to f of B minus f of A over B minus A. Now, let me just pause right here so to say something to you critically. Every single one of the something them that we use in unit 1, including this one, has some formulation, true or false?
True.
Mm-hmm. So what you need to do, guys, I beg of you, I implore you, I ask that you know the formulation so it is that you can't get off. All right? But what you need to remember here now. So when you find f dash of C, you recognize f dash of C is 5. And 5 does not lie within that interval AB, because remember the interval AB is -1, 1. So you now have to substitute this for the differential. So you have to differentiate the function because you have two differentials now. So both differentials must be equal. You have a differential which is 3x squared plus 4, and you have this differential here, which is f dash of C is equal to 5. So this now becomes f dash of C, which is going to be equal to 3x squared plus 4 equals 5. See it right here, so? And then I am going to be solving for the value of C, or values of C in this case. So I'm going to get C to be equal to plus or minus the root of 1/3. When rationalized, gives you root 3 over 3. All right. And that's what it is. Really not difficult.
Sir, and you, sir, and you said we don't need to worry about the rationalize.
Yeah. Yeah. I wouldn't worry too much about the rationalization just yet. I wouldn't worry about it
Just
because
yet.
if it gave,
Okay.
yeah, if you give me this as an answer, I'll mark it. Let me, and I'm using just yet because I am still going through the syllabus as I prepare for you from week to week or class to class. I am hugging the syllabus very closely because I want to make sure that I do justice to it, so that there is no question that comes on the paper that you're not familiar with. Similar to what it is that you would have done for the calculus one, you're able to, to recognize the questions. I want you to be able to so recognize and do a little bit more than the recognition, but to answer the questions well. All right. Okay. So this is where I want us to go now. This is where I want us to go. The mean value theorem for integration is an X formulation. But as you saw in the example I just did, the mean value theorem for differentiation, we had to differentiate. So by extension, the mean value theorem for integration, you would expect us to integrate. All right. So let PQ be part of the curve, the graph of a function y equals f of x. And this is my PQ here. All right. Then now, I'm going to let PA, which is this line here, QB which is this line here, be coordinates at P and Q. See it here? So remember, when we're doing our integration, it's the area under the curve that we are integrating. So my A, my PA, and my QB forms that area under this curve, PQ. Let PQ be part of the graph of the function y equals f of x. PA and QB be coordinates at P and Q. And I'm saying that OA, my OA is equals to A, and my OB, the whole length of it now, is going to be equals to B. So from here to here is like a vector, it's going to be equals to A, and then my OB is going to be equals to little b. Then the area of the region under the curve APQB, the area under the curve here, AQPB, is going to be given by the integral of f of x dx, using my upper limit b and my lower limit a. The same little b and little a we're talking about, right? But sir, we know this. Yeah, you do, because we've done integration. Watch me. So I'm going to let ABCD be a triangle. ABCD be a triangle with equal area to that of
Triangle.
You know what I mean, don't you? See what I'm calling triangle? ABCD. Yeah, a rectangle with with equal area. Thank you, hon. Equal area to that of APQB. APQB. So this rectangle is going to be equal area to that of my area under the curve. That is this piece here from up here. So I'm going to let DC meet the curve at L. This DC line is going to meet the curve at this point. So this L is a point on the curve PQ. Look at what happens. I'm going to draw LM parallel to the y-axis. This LM, I'm drawing parallel to the y-axis. Parallel means the two of them line up. This line, the y-axis line, and the line up, we're in the same direction, and guess what? They will never, ever, ever, ever meet, right? So that's parallel. To the y-axis, to meet at the x-axis at M. See here, so meet down here is at M. As the area of rectangle ABCD is going to be equals to AB times LM. AB times LM. Sir, duh. I mean, that's what we know. That's what we do in little school. So if this is a rectangle ABCD, this area LM is going to be the height of the rectangle, and this is going to be the length of the rectangle. So it's going to be AB times LM. See that, sir? See here, AB times LM. Length multiplied by width. Then the area of LM is going to be the area of ABCD over AB. Area of ABCD over AB. Similarly, the area of APQB, which is this one here, is also going to be over AB. And then I'm going to end up with that. What it is that I just did a while ago was just to prove the mean value theorem for integration. And somebody may say, sir, I am not interested in the proof. Just give me the formula, we can work the formula. Fair enough. I will give you the notes so you can reread it, but I have to show you because I've never been guilty of just going to a class and just giving students a formulation without showing you the derivation of the formula. You have a better understanding as to what is happening. Yes, I know it's a lot of A, B, C, D, and I don't have everything on one page for you to look at it. So you can go back and look at the stuff. But this LM, which is going to be the integral of f of x dx over b minus a, is where I want to put our focus for tonight. Why? LM is called the mean value of the ordinates. Is it a word here? Ordinates. Listen out for it. You will hear more of it. It's a new word that I'm introducing you to, and I want you to know it. I want you to be able to describe what it is. So you will give us a description? No, I'm going to tell you, but you are going to be able to describe it. So LM is called the mean value of the ordinates of the curve for the interval A to B, from x equal A to x equal B. So this is my mean value theorem. So it means that I'm going to integrate my function, my given function, that's what it means, using the upper and the lower limits over B minus A. Oh, sir, so that B are the same B like here, so. And this A, sir, are the same A. Okay, sir, I think I get it. So remember, the mean value theorem for differentiation is going to be f dash of C is equal to f of B minus f of A over B minus A. That's the mean value for differentiation. The mean value of integration is going to be f of C is going to be equal to the integral of f of x dx, BA over B minus A. Best believe that the denominators for both are the same. All right, let's go. It says to determine the value or values of C, guaranteed by the mean value theorem for integrals for the function y equals x squared over the interval 0, 4. Rockstone, sir. Let me see if we get what that one else says, sir. We need to determine the value or values. Oh, that means we don't know if I 1 or 2 or 3 or 4. Of C. Oh, but sir, you said that C is going to be a number that lies somewhere betwixt my interval. Oh, so that means that C are going between 0 and 4, sir. Then, sir, if you get C to be more than outside of the interval, that can work? No, because C lies within. All right, let us check it. So we need to determine the value or values of C guaranteed by the mean value theorem for integrals for the function y equals x squared over the interval. What's the first thing you're going to do? Let me see if you're thinking. What's the first thing you're going to do?
Differentiator.
Integrator.
Integrate, Sash.
Integrate.
Right. So what's the upper limit?
4.
4,
And the lower limit?
0.
0.
All right. I am going for some water. I want you to integrate this function for me. And then you're going to tell me the value of the integral. Very good. Start from it, please. I give you 2 minutes to integrate it. And it's a definite integral because you know the upper limit and the lower limit. So the integral is definite. All right. All of you, please, not only one. I'm going to call upon somebody, anybody, to tell me what your integral is. All right. What was your integral?
Sir, 64/3.
64/3?
Same.
Yes,
Yes,
sir.
sir.
Everybody got that, or somebody got something different? Ah, excellent. So it's going to be 64/3. And then remember what the final part of the mean value theorem says? B minus A. So over 4 minus 0. Talk truth.
Sir.
Talk to me now.
Yes, sir.
Yes, sir.
So similar to what it is that we have before, we're going to have our C squared to be equal to this. 64/3 over 4. So I put it over 4 over 1. For ease of calculation. Okay, all right, no problem. Thanks for your honesty. For ease of calculation, I'm going to have 64/3 now multiplied by 1 over 4. See here? Now multiplied by 1 over 4. And multiplying across. Sasha, see this?
Yes, sir.
I copy the same thing. I was supposed to do something else, but I copied the same thing. So you have to see with me. I wanted to show you something. I like breaking things down so that when you are reading over your own, nobody has to be wondering. So look at what happened. So this 64, this 4 going to 4 one time, and 4 into 64 goes another time, 16 times. So 16 times 1 is 16. And 3 times 1 is going to be 3. So I'm going to have 16 over 3. And of course, I'm going to find the square root of 16/3 because I don't want C squared. I want C. When I find the square root of that, I'm going to get all of this, which is roughly 2.31. And guess what? Remember, our interval was 0 and 4. So 2.31 C lies within our interval 2 and 4. So I know that works. I think that's what the question answers to find. The question did say to us to determine the value of C guaranteed by the mean value theorem for the integral, right? So this is going to be guaranteed. I was doing a graph here, but x squared. All right, let us leave that out for now. Do me a favor. I want to show you something. Oh, look at this here, guys. You see when, I know you guys know how to integrate. Every one of you, all 18 of you, 17 of you in class tonight, I know you know how to integrate, right? I spoke confidently about differentiation because I was doing applications to differentiation. I will now speak confidently about integration because I know you all know how to integrate. Now let me just caution you on something. So all of you in class just now got your 64/3. But you know the formula that says it's supposed to be over b minus a. So you'll go ahead and say, okay, 4 minus 0 is 4. So you will divide 64 thirds by 4. But remember, that is f of c, you know. That's f of c. Now, let y be equals to x squared, which is what the function that was given, which is also equals to f of x. So it's going to imply that f of c is going to be equal to c squared. Because if substituting c in the value here, it's going to be equal to c squared. So remember, it's not just to divide the 64 thirds by the 4 over 1 and call that c. It is going to be c squared as is defined by the original function. You notice for the mean value theorem here, c was defined by what was inside here. I am substituting my x now for the value of c. So I can say c is equal to that. If c is going to be f dash of x, is now going to become f dash of c. So I have to substitute c into the original differential. Here, I'm substituting the value of c in my original function. So it's going to be c squared. Then, sir, what if it was x squared plus 2? Then it becomes c squared plus 2. All right? That's what I just need to point out, because I suspect, it's all I'm good with the bridge in Germany. I suspect Germany against a third and say 16 thirds. But then again, no, Germany couldn't tell me 16 thirds because 16 thirds is 5 and 1/3. And 5 and 1/3 don't lie in this region here. 5 and 1/3 don't, 5 and 1/3 lies outside of the region. So that means that that's not a guaranteed value of C. All right, so just remember that you have to do something like that. All right. I want you to try that one for me. Let me just walk you through quickly. The first thing, integrate the function. You know what f of x is, or you know what y is. You know your upper and lower limit. It's always going to be over b minus a. You're going to substitute c into the original function. Start. 5 minutes. Somebody say something? Okay. Hi. We soon finish. We soon finish. Students, I don't understand. Are you complete with the integration of y equals the root of x?
Yes, sir.
Yeah, but I did say to you when you finish, say something to me. What is offer the answer? Upper limit is 9, lower limit is 1.
Yes,
What is
sir.
it?
Sir,
What's the
I
solution?
got 4.163.
4.163.
But oh, for that part you're talking, yeah, I got 52 over 3, sir.
Got 50 over 3. And when you do the division, you got
0.163.
is that the same thing as 13 divided by 6? Explain your 1.63 for me, please. Because remember, the upper limit is 9, the lower limit is 1. 9 minus 1 is 8. So what I did was also put 8 over 1. And the reason I put it over 1 is so that I can, when I invert to multiply, I'm going to get 1 over 8. So I'm getting remember, you know, I'm substituting the value of c into my original function, and the original function in this case was y equals the root of x. So it's going to be y equals the root of c. Did I make an error with the calculation? Somebody talk to me, please. Because I'm getting...
Sir, I made an error.
Oh, okay. But I want to hear the rest of you though. Come talk to me. Talk me through it, guys. I want to hear it.
Sorry, I can scroll back up to differentiation. Yeah, integration. I think I made a mistake.
I'm Jeremy, and you are very close. Yes, for me.
When you rearrange your okay, I see the error that I made. I see the error that I made. I was treating it as if it was a denominator, not a standalone.
Oh, okay. Make the correction quickly for me, please. Can I give it 2 minutes to make the correction, please? Where's Nico? Only nothing class tonight?
Not home, sir.
Where's Nico?
She's not home.
Oh, can somebody tell me why can somebody tell me why Karika is so silent? It's one of two things, you know. Is either she not learn it or she drop asleep. Karika, unmute for me, please. They don't hear nothing from me the whole night. Abby, you're not talking to me tonight. Mr. QC, I need to hear more of you.
Sir, question.
Yeah.
Three half. What you doing it? 3 over 2.
Which 3 over 2 for me?
3 over 2. Yeah, the 3 over 2. 2 times 9 to 3 half.
Oh, what I did is I just put 9 in the calculator and just raise it to the 3 halves and I get 27.
Okay.
Because 9 squares, because 9 squares is the same thing as, sorry, not 9 squares. 9 is the same thing as 3 squares. And remember the law of indices? Those two, I just want to show you what two will cancel out. So I'm going to do 2 times 3 raised to the 3 power. Give me half a second, Sash. Let me just type this thing here and show you what it is. So I will end up with, so this is what is going to happen. So my 9 is the same thing as 3 squares. So I'm breaking up my 9 into 3 squares, and then the 2's will cancel out. So I'm going to be left with 3 to the 3rd power.
Okay, sir.
Now 3 to the 3rd power is 27, and 27 times 2. So it explains all of that. All right. So I'm hearing Jermaine says that, and I'm sensing that he's understanding, but you know, he's very honest tonight, saying that, boy, sir, I made an error, and this is what I want of you guys. Talk to me, even if you're understanding fully. Let me know, because I want to be able to differentiate and to help those who are not following what is happening. Now, Jermaine, work with me, and the rest of you do the same thing. I want you to press 9, Jermaine. Press 9 on the calculator. Clear the calculator. Clear the calculator. Make sure that it is fully cleared, and if you're not sure how to fully clear it, just turn it off and then turn it on. Then press 9. Then press your upside down V somewhere in the middle of your calculator. Then you're going to open your parentheses. Open your parentheses. Then you're going to press 3 divided by 2 and close your parentheses. And tell me if you get 27. Equal, and tell me if you get 27.
Yes, sir.
Yes,
Yeah.
sir.
Yeah. All right. Right. So in situations like these, and especially when you're using like the cheaper versions of the calculator, it does not recognize syntax, right? So you have to be able to be on the safe side, and which is why I'm saying to you, please, my students, I beg of you, you need to get your calculators now, so that you know how to manipulate your calculator, and especially to understand the algorithms that come with it. All right, with the calculations, that is. So when you're doing, so Jermaine, you know when you're raising something to a fractional power, you have to include your parentheses. If not, it's going to give you an incorrect answer. Very, very, very important for you. Very, very, very important. Are there any other questions?
Just need to practice more, sir.
Yeah. And as I said before, you remember, no, this is what I don't understand. Oh, this is applications of integration. So you have to make sure that your integration is where it's supposed to be before you can apply any stuff to it. Yes, Rush. So you have to make sure so you know your integration inside out. And then we can do some of these applications. All right. So I'm going to get that. Let me see if I have another one for you. All right. See, I give you an easy one here now. I'm giving you exactly 7 minutes. It's not 6. I'm going to come back to you. Start on that one, with that one.
Sir, I just send you a WhatsApp. Can you check it, please?
Okay, sir.
So what are the numbers? 2 and 10? The interval
Yes,
size.
Lexman. Yes, yeah, 2, 2, 10. I'm not hearing from you guys. Has anyone completed the question? The integral?
Sir, the integral is 120.
So the integral is 120.
The integral is 120, all right. Anybody got 120?
Yes,
Anybody
sir.
else got 120?
Yes, sir.
All right. What next?
Minus B from minus A from B.
All right, and you're going to get 8. Okay, good. So my integral is also 120. And B minus A is going to be 8. So it's going to be 120 divided by 8, which is somewhere anywhere between 30 over 8. No, 30.
It's exactly 15, sir.
Right. Hold on. Oh, yeah, yeah. But look at this here now, though. $120 divided by 8. Okay. So I saw you get that. I saw you get the 15. So you have 2x. Let me just put that there in case somebody may have gotten it some other way. See, I've gotten 2c plus 3 equals 15.
Yes, sir.
So 2c equals 12, c equals 6. So you got c equals 6, right?
Yes, sir.
Everybody? Jermaine, what you get?
Sir, I never read so far now. I kind of dip on the right track.
Nice. Next time. The rest of you are so silent.
Hey, can I scroll up a little bit more, Mr. Something?
No problem. Let me just call on some people.
I saw my error, sir.
Okay, cool. Anton, you're not allowed to come to my class next week if you're not going to unmute and participate. I'm literally calling out students now. Miss Wint, you're not allowed to come to class next week without unmuting to participate. Real talk. There's no way you guys can come to class and just sit down and just talk to teacher and contribute to the class. All right, so I'm giving you enough notice. Today is how much? Today is Thursday, Friday, Saturday, Sunday, Monday, Tuesday. 5 days to think about it. You are not allowed to come to class next week without contributing. You can't sit down in a class, no, it no work. So no, real talk. Thank you. I need to hear from you guys. All right. And if needs be, and come next week, you guys don't talk, I'm asking the students to send me their work in WhatsApp to my WhatsApp, and I will send them the solution. There's no way you can sit down and not participate. I need to know the errors that you're making so that I can undo those errors.
But sir, if you do that, we'll just send the work as well.
What you say? No, tell me what you say a while ago.
I'll prepare to talk next Tuesday.
Okay, bless your heart. Thank you very much, Miss Wayne. Love it. Mr. Alton Brooks, I'm waiting to hear from you, you know. Can't come to class and sit down and not say nothing. No, man. All right. Noted, sir. Okay, sir. Thank you, please. Sean is absent from class. All right. There is, all right, what I don't want to do tonight. I don't want to do tonight. What I wanted to look at is, all right, let me just say something here. I wanted us to, all right, so ask a question here. I had to ask a question here. Can you identify the value or values of C in the graph above? C is 6. But it's difficult for you to see it on this graph because of how the graph is drawn. But I'm saying to you that it's the midpoint. All right, but let me just say something here. All right. What am I looking for? All right, so I'm saying here, if you can identify the value of C in the graph, and I'm saying that the interval is 2, 10, we can see that the average of the interval limits result in the exact value of C in this particular question. So if you look here, you see that, well, we calculated our C to be equal to 6. But when we look at the average of the intervals, it gave us the exact value of C. Does it work all the time, sir? Well, this is a question. 2 plus 10 is 12, divided by 2 is 6. But my interval here is 9 plus 1, which is 10. The interval is not 5. What the interval is? Interval is 4.69. But sir, when you round it off, you can get 5. Okay. So it doesn't work all the time where you get it to be exact. All right. These are something to take note. All right. All right. So I'm giving you just one more question, but before I give the question, I want you to have some, it's like a summary point. It's like a summary point. And one of the things that I tried to do, I think I did it last class, is just to show you, is just to summarize the steps that we take when we're looking at the mean value theorem for integration. Some take-home points for the MVT. If it concaves up to the right, well, let me leave this one here until we look at the graph. You see, I have the graphs here, but I deliberately not go to the graphs tonight because this graph is slightly off because I'm not seeing the midpoint C there. I can see what I'm looking for right here, but my aim is not for the graphs really for tonight. Well, this graph is clearly shown. My aim is not for the graphs tonight. So let us leave this piece here and let us just do this one as brought up. We're doing this last one here as brought up. Find the value of C that satisfies the mean value theorem for the integral on the limit here 0, 1 for the function f of x is equal to x times 1 minus x. Now you recognize that so far this may be the most complicated function that we get. So I can't tell you what function I'm going to give you to work with. All right. So you remember your integration now will have to be, matter of fact, let me ask you, what would you do in order to fix up that function? X times 1. Okay. What would I do with that function to integrate?
Is expansion on the term, sir?
Very good. Very good. Very good. All right, go ahead and expand.
Learned something from the other night when Ryan said it, you know, someone just hold on to it.
Yeah, man. Hold on there. Go work on that one for me, please, guys. And then very good, Yannick. I'm just checking the chat.
Sir, that is a equal sign in front of the X or a minus. Sir, you're muted if you're talking.
Equal.
F of x is equal to x times 1 minus x.
Okay.
Where we reach, guys? Where we reach?
Sorry, I'm stuck.
You stuck? Also, so you have x minus, you have x minus x squared. When you integrate x, you can get x squared over 2 minus x cubed over 3. And then you substitute in theorem. That's what you got, Charles?
Repeat, sir.
You can have x minus x squared. And when you integrate x minus x squared, you can get x squared over 2 minus x cubed over 3.
Yes, sir.
Yes, sir.
Somebody saying, sir?
Them say yes, sir.
Oh, because I don't have the workout. It's just to answer me, huh?
Sir, I don't know how to transition it into the C, because I would have C minus C squared, but I don't know where to go from there.
Right. So you have C. Oh, yeah. You have C minus C squared.
Yeah,
If you get a quadratic. No. If you get a quadratic, C minus C squared equals what?
Equal 1/6.
Yeah, C minus C squared equal 1/6. So you may have to use a quadratic formula for this one now. And the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4 times a times c. I was tired. No? Use a quadratic formula. And sure. Copy. Paste. So you use a quadratic formula. So you will end up with c minus c squared. Very good. C minus c squared is equals to, you said 1/6. So you have c minus c squared equals negative 1/6. So c minus c squared, c minus c squared. All right, c minus c squared equals negative. No, yeah, equals negative positive 1/6 or negative 1/6 is what?
Positive.
Positive 1/6. Oh, come on, why do I keep doing this? Copy. Paste. So I'll get something looking like that. C minus C squared equals to that. And then transposing gives copy. I don't want any negative C squared. So transposing is going to give me, come on, insertion. C squared minus C is equals to plus equals 0. So it's no, so minus 1/6. I'm multiplying through by negative 1. multipl, multiplying through by negative 1.
Sir, if you bring over the c squared and the c, oh, you get -6.
I get minus 1/6.
Yeah. If you bring over the C and the minus C, if you bring over
Oh
the
yeah.
C and
Yeah,
C
yeah. It's
squared,
supposed to be positive 1/6. Supposed to be positive. There's an equal sign right there. Yeah, you're correct. You're correct. So it's gonna be, well, yeah, actually, if I multiply through by -1, I'm gonna have this becomes a negative C, a positive C squared equals a negative 1/6. And then when I transpose it becomes positive 1/6. Yeah, so that's correct. Yeah. So A is going to be 1. Cut, paste. A is going to be equals to 1. What is the value of B? B is equals to -1, don't? Somebody say yes. By the way, anybody remember how to use this? And C is equals to 1/6.
no,
Anybody
sir.
know? Anybody remember how to use the quadratic formula?
Totally forgot, sir.
No, sir.
Boy.
Sir, that in a subconscious brain.
Oh Lord. I have to use this because it is not, I can't multiply the coefficient of x squared by the constant to get my real factors. These factors are imaginary, so I have to use a quadratic equation to solve. I must use a quadratic equation to solve in this case. So what we look at in the quadratic equation is to look at the coefficients of my terms. So the coefficient of c squares is 1, which is my a. So this is going to be the coefficient of c squares is going to be a, so a is 1. The coefficient of c is going to be -1, which is my b. So my b is -1, and my constant is going to be positive 1/6, which is what I get my c to be at. And then now all I'm going to be doing is substituting all of these into my quadratic, and I should end up with this. All right, so let's just try that and then we'll come to an end. Copy, paste. B is -1. So anywhere in the function I see these variables, I'm going to put them down. I'm going to make my substitution, so which is one of the easiest formulas to work with. But I'm going to say it again. Can you agree with me that most of what it is that we are working with so far are all formulations? Hold on, you know. Something that you have done on paper is incorrect. No, it is correct. 4/6, okay, it's correct. So all I'm doing is just making a substitution. So minus b, so it's going to be minus a -1 because b is -1, plus or minus the square root of b squares, which is -1 squares. B is -1, so it's -1 squares. Minus 4 times a times c, minus 4 times a is 1. C is 1/6, all over 2 times a, which is 2 times 1. So all I'm doing here now is just simply evaluating -1 times -1 is going to give me +1. 1 squared, -1 squares is simply 1. 4 times, that is going to be just 4/6. And 2 times 1 is 2. Watch me. And then, what is 1 minus 4/6? That's 2/3. 1 minus 2/3 is going to be 1/3. What is 1 minus 4/6? Is it 1/3? So they don't talk to me. When I look at this in an exam here,
Yes, sir.
it's going to be 1/3. And that now is copy equal paste. Oh no, undo. Let me just see if I can. So all of this now is going to be equals to 2 different something. Let me just carry this over. Put this under that. And I'm going to just leave you with this one. You go figure. Go figure. So what I'm saying to you, you see my answer? Oh Lord. Okay, forgive me. I'm using X right here because I have a C up here. I have a C up here, so I don't want to confuse it with the C's. So you can see how my half came out nicely. My 1/2 came out nicely. You are going to work on this one for me. The root of 1/3 divided by 2 to see if you get the root of 3/6. So
Sir,
all of this. Go ahead, Raf.
Sir, I get 6/6.
No, 6/6 won't work. Not correct.
I'll check it.
I'm saying to you that this answer here is exactly the same as this answer here. We see all the 1/2 came out nicely. But now we want to see all the root of 1/3 divided by 2 is going to work out to the root of 3/6. That's next class. You're going to do it for me and then we'll discuss it in next class. All right, now do me a favor, guys. As a wrap up, I'm going to say to you how important it is that you become active learners in this space. Active learners in this space. For the face-to-face delivery, we are trained to read body languages. We are trained to read facial expressions. So we can know the ones who are understanding from those who are not understanding. But when you come to class and you don't say, boy, sir, you know, maybe I can error right there. So I won't know that it's you putting in the information wrong in your calculators. And then afford me the opportunity to clear up that misconception, because you will hold on to that misconception right through to exams and it's going to hurt you. So please, I want to hear from you, whether or not you're understanding. If you understand, sir, clear as mud, I'm understanding, sir. But I don't want, I'm really not going to go through the whole time with others who are not participating. And if you decide, say, you have a good morning, sir, or good night, sir, and that is it, it's still unacceptable. I want to know that you are learning. All right. So you can see, yes, hon.
I was going to ask you how you get the square root 3.
No, man, that's your homework. You can figure it out for me. This piece here, you can figure out for me for next class. Yeah. All right. Finally, I know I have received 2 messages from Wint and Christine re-Edico. Nesta, are you there on Edico? All right, I guess not. All right, so guys, the work is there. I know it's a lot of work, meaning that you have to do in total, but please don't let the work pile up on you. Start working on your calculus too. Very important. All right, I'm going to see if I can send this off to you tonight so you can have some stuff. I will begin trapezoidal rule. I need to finish off some stuff on this one, but I'm going to start trapezoidal rule. And yes, there is another formulation. See, so long that formulation is, there's another formulation for the trapezoidal. All right, and matter of fact, the trapezoidal comes with 2, one big one and a little one. All right, so we will talk. All the best. Remember to say, gentle Jesus. We'll talk.
Sir.
Yeah,
Sir,
Nice.
you're sending this document in the WhatsApp group, right?
Yeah.
Cool.
Sir, I sent you a message, direct message.
Sir,
Oh, you
remember
said,
recordings.
you remember Friday what?
Remember the recordings.
I have been sending the recordings, checking.
I think they're up on YouTube.
No,
Yeah, man, I
but
sent some Yeah, man,
No.
check them, and I sent some recordings the other day. All right. Yes, Alton, I see that. All right. Thanks, guys. All the best.
Cool.